Lesson 2, Writing Equations to Model Relationships, Part 1. Learning target, I can use letters and numbers to write equations representing the relationships in a situation. In this lesson, we're going to practice writing expressions and equations to model various situations. Similar to this video, you'll begin by creating models where the values are known and move towards models where the quantities are unknown or can change. Let's take a look at an example. Suppose your class is planning a trip to a museum. The cost of admission is $7 per person, and the cost of renting a bus for the day is $180. Write an expression for each quantity described below. As we learned in the previous lesson, models such as expressions and equations are helpful when a quantity or constraint changes. In this case, we're going to consider the cost of two different amounts of students and teachers attending the trip. The museum has the same cost of admission for students and teachers, $7 per person. Therefore, we can find the sum of teachers and students attending the trip and multiply the sum of this number by 7 to find the total cost of admission. The cost of renting a bus is $180 and is a fixed quantity. We can add this to the total cost of the admission to find the total cost of the trip. Therefore, the expression 7 times 24 plus 3 plus 180 represents the total cost of the trip. What expression could we write to find out the cost if 30 students and 4 teachers attend the trip? The cost of admission is still $7 per person. The cost of renting the bus for the day is still $180. The quantities that change were the number of students and teachers attending the trip. Therefore, we can replace 24 with 30 for the number of students and replace 3 with 4 for the number of teachers, respectively. Notice that the numbers of students and teachers can vary. This means the cost of admission and the total cost of the trip can also vary because they depend on how many people are going. Next, we're going to consider the same situation. However, some of the quantities are now unknown. Now we will create a model for unknown or changing quantities. This time we'll write an equation to model the quantities and constraints if S represents the number of students, T represents the total number of teachers, and C represents the total cost. Take a minute to reread the situation. Considering the situation, which variable makes the most sense to be isolated on one side of the equation? Since the situation is about finding the total cost of the trip, it makes sense to write an equation that would determine the total cost of the trip for varying amounts of students and teachers. Therefore, we'll start out with the equation C equals. Next, let's consider the cost of admission. Think back to the expression we wrote on the previous slide. We multiplied the sum of the number of students and the number of teachers by the cost per person. We can write 7 times S plus T to represent the total cost of admission. 7 times our students plus teachers inside of parentheses. Lastly, we have to consider the cost of the bus. How can we account for the cost of the bus in our equation? To find the total cost of the trip, we must add the cost of the admission and the cost of the bus. Therefore, we can add $180 into our equation. So we want to add 180. In this example, the bus rental costs $180 regardless of how many students and teachers are going. Assuming only one bus is needed, 180 is an example of a quantity that is a constant. What would happen if the cost of the bus was unknown? Letters can also be used to represent quantities that are a constant. We might do this when we don't know what the value is, or when we want to understand the relationship between quantities rather than the specific values. Let's let B represent the bus rental fee. Which equation represents the given situation? C equals 7 times S plus T in parentheses, and then we're going to add the bus cost. C equals 7 times S plus T plus B. In this video, we reasoned repeatedly. Compared to the last equation we wrote, the only thing that changed was that the bus rental fee became unknown. We simply replaced 180 with B to represent this unknown fixed amount. In this lesson, we learned that we can use numbers or letters to represent the quantities in the situation. When might it make sense to use letters? It makes sense to use letters when there are quantities that vary. In this situation, the quantities that vary are the number of students, represented by the letter S, and the number of teachers, represented by the letter T. Quantities that stay constant are fixed. They may be represented with a number or letter. What quantity remained constant for this equation, representing the cost of the field trip? The bus rental cost, $180, remained constant. The bus rental cost of $180 regardless of how many students and teachers are going. In the next lesson, we will continue to develop our ability to identify, describe, and model relationships in mathematics.